Okay, so this numerical example, which is 4 divided by 69, is taken from the Jane Merriam book and is one of the numerical example in your tutorial sheet. So when the rocket reached the position in its trajectory, so this is the position, it has a mass of 3 megagram and is beyond the effect of Earth atmosphere. So data is given. The first thing is you are given is the mass, which is 3 megagram, which is going to be 3,000 kilogram, and is beyond the effect of, okay, gravitational acceleration is given. So g at this point is 9.6 meter per second square. Fuel is being consumed at a rate of 130 kilogram per second. So this is our dme divided by dt, which is 130 kilogram per second, and the exhaust velocity relative to the nozzle is 600 meter per second. So this is our v of d relative to e, or v of e relative to d, which is the same thing, is 600 meter per second. Compute the n and t component of acceleration of the rocket. So what you need to calculate, requirement here, is that you need to calculate the a in the t direction, and you also need to calculate a in the n direction. So this question obviously have two parts, a and b. Okay, so this is the case which is given. So now to solve this problem, it will be easy if we draw first the free body diagram. So if we consider this rocket here, and obviously the gases are expelled in this direction here, uh, and this angle is given, which is 30 degree, and the the weight is going to be in this direction, mg, which should have two components, one in the one in this direction and one in this direction here. So this is the direction which is given to us. So this is our t direction, and the other direction which is given to us is this direction, which is our n direction here. So the weight should have two components, one in t direction, one in n direction. And if this angle is 30, so this angle should also be 30 here. So this component will become mg cos 30, and this component will become mg sine 30. Okay, now we can use the equation that we derived in the theory part. So the equation was summation of forces on the control volume is equal to m dv by dt minus v dE and dme divided by dt. So this was the equation that we derived in the previous case. So in this case, as you can see, uh, the external forces, because we are ignoring the drag force, because there's no information given, so we will just ignore the drag force. The only force that we will consider in this case, which is external force, is the weight. So now if we consider, we apply this equation, we can apply this equation in t direction and in n direction. So in the part a, if we apply in t direction, and if we take this is our positive, So then we can apply the forces. So this is mg sine 30, which is opposite to t. So this will be negative. So mg will be minus sine 30, and then you will have equal to, so mass of the rocket is given at this particular time, which is 3000, and dv by dt will become the dv tangential, or we will call it just vt, divided by dt, and minus vde. So you are given vde, which is 600, and you are also given dme divided by dt, which is 130. So everything is given here. uh, so now you will put the value of mass here, which is again 3000, and again g is given, which is 9.6, and sine 30 equal to 3000, and then this term, which is dvt divided by dt, which is the just acceleration in tangential direction, so we can call this at, and minus 600 times 130. So if we just do the only unknown here is at, which we can calculate. So at will become equal to uh, is 21.2 meter per second square. So this is our acceleration in the t direction. Now in part b, we need to calculate the acceleration in the n direction. So now we can apply the same equation in n direction. Okay, so in the n direction, we have mg cos 30, and it's in the positive n direction, so it will be positive. And on the right hand side, we have m, which is again 3000, and dvn divided by dt, so velocity in the n direction. And now in the n direction, because the fuel is only moving in the t direction, there is no fuel in uh, in the in the n direction. So this means that this term will be 0. Okay, so now in this case we can put the value, so that will become 3000, and the acceleration is given g, which is 9.6 cos 30, and dvn divided by dt is an. So this is our an here. Now from this equation, the only unknown is an, which we can calculate, and which will become 8.314 meter per second square.